Hello students, welcome to maths class. So we are dealing with the parabola, right? So 7 marks questions we are dealing. So in previous question we find the angle between the two parabola equations, right? So now we will go to one more 7 marks question. So this is important for 7 marks question. Prove that the area of the triangle inscribed in the parabola y square is equal to 4ax is this one. Okay, so come on, now you take the solution. So how we will prove it? First you take what is the given parabola to you, right? So given parabola is y square is equal to 4ax, right? And here it is given that the area of the triangle inscribed in the parabola. So one triangle is inscribed. Inscribed means it lies inside the parabola, right? So we have to prove that area of the triangle is this one. Okay, one parabola is there. Inside the parabola one triangle is there. Okay, triangle is covered by the parabola. So this triangle is inside the parabola. We have to find that triangle area. Okay, so come on, how we will find? First you take the 3 vertices of the triangle, then find the area. So come on, let A x1 y1. We can take these points in parametric form. You know it, how to take the parametric points in parabola, right? So it is a t1 square 2a t1, right? Next b x2 y2 is equal to a t2 square 2a t2. Next c x3 y3 is equal to a t3 square 2a t3, right? Are 3 vertices of a triangle. Vertices of triangle ABC inscribed, right? Inscribed in parabola. It is inscribed inside the parabola. Okay, so now we have to find area of this triangle. So therefore area of triangle ABC is equal to, what is the formula? Of, right? Modulus of, it is x1 minus x2 y1 minus y2. x1 minus x3 y1 minus y3. Right, so is equal to 1 by 2. Come on, so x1 minus x2. x1 minus x2 means, see, this is your x1, this is your x2. So we can take a t1 square minus a t2 square. Next y1 minus y2, it is 2a t1 minus 2a t2. Okay, next x1 minus x3, so it is a t1 square minus a t3 square. Okay, so it is 2a t1 minus 2a t3. Okay, so from this we can take 1 by 2 of this. So from this first row we can take a common, and from the second row we can take one more a common. So a into a, from the first row 1a, from the second row another a into a square. So a square by 2 into, it is t1 square minus t2 square. Next 2 into t1 minus t2. Similarly here t1 square minus t3 square into 2 into t1 minus t3. Okay, so this is of the form a square minus b square form, right? So we can write a plus b into a minus b. So is equal to a square by 2, right? Modulus of t1 plus t2 into t1 minus t2. Okay, so here 2 into t1 minus t2. Similarly, here we can take t1 plus t3 into t1 minus t3. Okay, so t into t1 minus t3. Okay, so is equal to a square by 2. From the first row, we can take t1 minus t2 is common, isn't it? So we can take t1 minus t2. From the second row, you can take t1 minus t3. t1 minus t3, t1 minus t3 common. Okay, so then you will have t1 plus t2 2 and here t1 plus t3 2. Okay, so AD minus BC form, right? So is equal to a square by 2 t1 minus t2 t1 minus t3 into, come on, AD minus BC. How we will take? We will take this as, how we can write this as 2 into t1 plus t2 minus 2 into t1 plus t3. Okay, so is equal to a square by 2 t1 minus t2 t1 minus t3 into, open the brackets, 2t1 plus 2t2 minus 2t1 minus 2t3. Okay, so come on, this is 2t1 minus 2t1 and 2 also can, okay, I will explain how it will cancel. 2 is common and here 2 is there, both will get cancelled. So a square t1 minus t2 t1 minus t3 and 2 is taken common, so it is t2 minus t3, right? Here by 2 is there, 2 cancel. So area means we'll take modulus of, isn't it? So we will take a modulus, right? So is equal to a square into t1 minus t2. Come on, next write in the order, next t2 minus t3 comes and why I have not taken, see, order should be t1 minus t2, t2 minus t3, then t3 minus t1. So you take a minus outside, so it is t3 minus t1. Okay, so inside the modulus, what I said, if negative sign is there, it becomes positive, right? So it is a square into t1 minus t2, t2 minus t3, t3 minus t1. Okay, so but actually what we have to prove? We have to prove y1 minus y2, y2 minus y3, y3 minus y1. But what is y1, y2, y3? 2a t1, 2a t2, 2a t3. So t1, t2 are there. We want 2a. So for this one 2a we need, for this one 2a we need, and for this one 2a we need. So totally 3 2a's we need. 2a into 2a into 2a, right? 2a cube. So I need that value means I am multiplying and dividing with that value. So 2a by cube by 2a cube, right? Then we can take this one as t1 minus t2, t2 minus t3, t3 minus t1. Okay, give 1 2a for the first term, next 2a to the second term, next 2a to the third term, right? And it is a square by 2 cube, 2 2s are 4, 4 2s are 8, right? 8 into a cube into, right? So 2a is given to it, so 2a t1 minus 2a t2, and 2a is given for the second term, so it is 2a t2 minus 2a t3, right? 2a is given for this term, so it is 2a t3 minus 2a t1. Okay, so a square cancel, right, is equal to, it is 1 by, what is that, 8a. Okay, modulus of at1, see what is at1, it is y1, so y1 minus y2. Okay, next y2 minus y3. Okay, next it is y3 minus y1. Okay, so this is the area of the triangle inscribed the parabola. So one triangle is inscribed, that means it lies inside the parabola, or triangle is surrounded by the parabola. Okay, then find that triangle area. Okay, so here we have taken the vertices. Here the points lies on parabola, isn't it? All the three vertices of the triangle, that means points of the triangle lies on parabola. So on the parabola, how we will take the points in parametric form? At square comma 2at. Here 3 points are there, that's why I have taken at1 square 2at1, at2 square 2at2, at3 square 2at3, like that we have taken 3 points here, right? So 3 points on the parabola, as well as these are the 3 vertices of the triangle. Now you find the area of this triangle ABC. So area of the triangle ABC is equal to half into modulus of x1 minus x2 y1 minus y2, determinate form, right? x1 minus x3 y1 minus y3. So half into, you know your x1, you consider this as x1 y1, x2 y2, x3 y3. Substitute. After the substituting from the first row, if you observe it, we can take a common, and from the second row we can take a common. First row a, second row a into a square. Okay, so it is a square by 2. What is this? T1 square minus T2 square, 2 into T1 minus T2. A square minus B square form, right? So a plus b into a minus b form I have taken, and from these two we have taken 2 common, 2 into T1 minus T2. So if you observe this, here in the first row T1 minus T2 is there, T1 minus T2 is there, so we can take T1 minus T2 outside. Similarly T1 minus T3, T1 minus T3. So from the second row you take T1 minus T3 outside. After that it is the determinant A, B, C, D, AD minus BC form. This into this minus this into this. Already you gone through all these things in your first year. Okay, so after that you open the brackets, 2t1 plus 2t2 minus 2t1 minus 2t3. So cancel them, plus minus cancels, so 2 into t2 minus t3. Okay, and also here 2 can be taken common, and here 2 can be taken from these two. 2 can be taken common, and then this common 2 and this 2 will get cancels. Actually directly also you can cancel, but we need the steps. This is 7 marks question, no? So stepwise you have to write. Okay, after that a square into, so area, no, we can write in modulus form. So I have taken a modulus, and try to write the values in order. So T1 minus T2, then T2 minus T3 comes, then T3 minus T1 should come, but we are having T1 minus T3. So we can take this as minus can be taken outside, then it is T3 minus T1. Okay, so inside the modulus, if negative sign is there, it will become positive. Already I said to you, modulus is a positive mission. If we keep anything inside that, it becomes positive, right? So this is the area of the triangle, but what we required is area of the triangle must be equals to 1 by 8a into y1 minus y2 into y2 minus y3 into y3 minus y1. Values must be in terms of y's, but we got the values in terms of t's. So first see what is y1, what is y2, what is y3. So your y1 is 2a t1, your y2 is 2a t2, and your y3 is 2a t3. So how we will get it? If you observe, t1 minus t2 is there, we need 2a for that. So 2a t1 minus 2a t2, then we will get y1 minus y2. That means for this term we need 2a. For this term here also, if you multiply 2a t2, right, minus 2a t3, that means if you multiply that with 2a, you will get 2a t2 minus 2a t3, right. So then you will get your y2 minus y3 form. Okay. So similarly, if you multiply this with 2a t3 minus 2a t1, y3 minus y1 form. So that's why for this term should be multiplied with 2a, for this term we need 2a, for this term we need 2a. So 3 2a's we want, that means 2a into 2a into 2a, that is 2a cube, right. So we have to multiply and divide with 2a cube. So 2a cube by 2a cube, and keep downward 2a cube as it is, and send this 2a cube inside the modulus. Okay. So then what happens? 2a whole cube, 2a into 2a into 2a, 2 to the 4, 4 to the 8, and a into a into a cube, right. So it is a square by 8a cube. Okay. So then your a square will get cancelled, it will be 1 by 8a, right. And this is y1 minus y2, y2 minus y3, and y3 minus y1. That is the required area of the triangle which is inscribed in a parabola. Inscribed lies inside the parabola. So where we used it lies inscribed the parabola means the vertices of the triangle lies on a parabola. So we have taken the points with respect to parametric equations of the parabola. So what are the points of parametric equations of the parabola means it is at square comma 2at, right. But here we are having 3 points on the parabola, 3 vertices of the triangle ABC, right. So that's why I have taken the 3 vertices as at1 square 2at1, at2 square 2at2, at3 square 2at3 are the 3 vertices of the triangle which lies inside the parabola. Okay. So this is your 7 marks most repeated 7 marks problem. Okay. So here thing is the triangle is inscribed, right. Inside the, inscribed means lies inside the parabola. So that's why you have to take the points with respect to parametric form, with respect to parabola form. In the parabola, how we will take the points with respect to parametric form means at square comma 2at, right. That is 1 point. Suppose 3 points are there. To make the difference of 1 point to another point, I have taken like this at1 square comma 2at1, at2 square comma 2at2, like that I have to take the points. Okay. So after that we have taken the formula area of the triangle, half into determinant, right. x1 minus x2, y1 minus y2, x1 minus x3, y1 minus y3 form. So then we have taken and we applied the determinant rules in the first year in trigonometry. You got one major part, sorry, in first year in algebra, not in trigonometry, we got one major part, that is matrices. In that matrices, determinant is one topic, right. So by using those determinant concepts, we are finding the area of the triangle here. So how? So we have taken the formula in terms of determinant. Next, in the determinant, if any row contains common term, we can take outside. So here A is common, common in the first row, you can take outside. Similarly, a is common in this second term also, you take outside. One a into another a square. So a square is taken outside, right? After taking a common, then you take 2 also common inside the determinant. Here also take 2 common inside the determinant. Then we applied a square minus b square form, a plus b into a minus b. Okay, if you observe the first row, again already I said to you, in the determinants if any term is common, take outside. So in the first row t1 minus t2 is common, take outside. In the second row t1 minus t3 is common, take outside. Okay, so we have taken that those terms which are common outside. Then it is determinant of the form a b c d, and its formula is ad minus bc. This into this minus this into this we have to take, right? This into this minus this into this. So like that we have taken, then opened the brackets, 2 terms cancelled, positive negative. From these 2 is taken common, and here downwards 2 is there, both will get cancelled. So this is area, no? So we can write area as modulus form, right? Area must be positive, right? Always area will be positive. So that's why area formula we will take it as modulus. So here also I have taken modulus. Okay, so and try to write the values in the order. So t1 minus t2, t2 minus t3. Next you have to take t3 minus t1, right? But here we are having t1 minus t3. Okay, so from this take a minus sign outside, minus t3 minus t1. Okay, so in the modulus, suppose minus sign is there, what happens? It becomes positive, right? Modulus of negative value becomes positive, right? Already I said to you, modulus is a positive mission. If we keep anything inside, it becomes positive. That means if negative value is there, it also becomes positive. Okay, so then t1 minus t2, t2 minus t3, t3 minus t1. Okay, but actually question is, show that the area of the triangle is, it is in terms of y's, not in terms of t's, but we got the values in terms of t's. So how we will get our values of y1, y2, y3 means, observe, it is 2a t1, y1 is 2a t1, y2 is 2a t2, y3 is 2a t3. So we need 2a for this term, we need 2a for this term, we need 2a. That means if we multiply this term with 2a, your values will be in terms of y. This term with 2a, your values will be in terms of y. This term with 2a, your values will be in terms of y. Okay, so that's why multiply. How we will multiply? We cannot multiply directly, we need this one, we can take. No, we have to multiply and divide, so that equation will be balanced. That's why I multiplied and divided with 2a cube, right? And keep this downwards 2a cube as it is, and send this 2a cube inside the modulus, right? So give 2a to each term, give 2a, 1 2a for this, 1 2a for this, 1 2a for this, and send 2a inside the brackets. What happens? 2a t1 minus 2a t2, 2a t2 minus 2a t3, 2a t3 minus 2a t1, right? Nothing but y1 minus y2, y2 minus y3, y3 minus y1. So that is the area of the triangle. Okay, so this already we solved previous class 1 7 marks problem, right? This is another 7 marks problem. I think one more is there, and 2 more 2 marks questions are there, right? With that we can finish our parabola. Okay, so practice the problems perfectly. So same thing again, see the method, don't by heart each and every step. So one thing is here, one triangle is inscribed inside the parabola. We have to find that area of the triangle, but it should be in terms of y's. You should remember like this. So you take the points. Actually inscribed, this triangle inscribed inside the parabola means those vertices of the triangle, points of the ABC are the 3 vertices. These ABC lies on the parabola. So you take these ABC points with respect to parabola points. In parabola, we will take the points in parametric form, AT1 to AT, right? First, if we want to take first one, AT1 to AT1, next AT2 to AT, like that we have to take 3 points, right? Then you take the area of the triangle. We have to find area of the triangle only in determinant form. Apply all the determinant rules and find out. And at the end, area should be positive. We have to take area formula in terms of modulus only. Then only we can get positive value. That's why I have taken modulus and write the values in order and try to get your y values. Okay, so practice this problem perfectly. That's all for today. Have a nice day.